Given f of x comma y equals the square root of the quantity y minus x, which of the following regions are in the domain of f of x comma y? The domain of a function of two variables is a set of all possible inputs, or a set of all possible ordered pairs, in this case, all possible values of x and y. So because we have this square root here, and f of x comma y must be a real number, the radicand, or this expression underneath the square root, can't be negative, which means in order to find the domain, y minus x must be greater than or equal to 0. It'd be okay to equal 0 because the square root of 0 is 0. This just can't be negative. So to solve this for y, we would add x to both sides, giving us y is greater than or equal to x. So if we graph this linear inequality on the two-dimensional coordinate plane, we'll know the region that forms the domain of f of x comma y. So first we'll graph the line y equals x, and then we'll determine where to shade. So if we're going to graph y equals x, this is in slope-to-intercept form, with the form y equals mx plus b, where the slope would be the coefficient of x, so the slope is 1 or 1 over 1, and the y-intercept, because there's no constant, would be 0. So notice how the line with a y-intercept of 0 and a slope of 1 would be this line here. And because y must be greater than or equal to x, that means we're going to shade above the line. So we would shade these two regions here. So this region here, including the line, makes up the domain of f of x comma y. And therefore, our answer is A and D. Let's also graph this three-dimensional surface and look down on the xy plane to verify this domain. So here's the graph of our surface. This would be the positive x-axis here, and this would be the positive y-axis. So let's rotate this so that we have the positive x-axis moving toward the right and the positive y-axis moving upward. So now if we look down on just the xy plane, like this, we can see that this does verify that our domain is correct. The domain consists of this region here, which would be when y is greater than or equal to x. I hope you found this helpful.